Hello, and welcome to Lesson 3 of Unit 5. A lot of people were asking me what the page numbers are, but I don't have a student workbook, so I don't know the page numbers. But I know it's the third lesson in your fifth workbook, so make sure you're working in the workbook that says 5 on the front. All right. Activity 1 is your warm-up, and we're going to just keep on working with these function tables. So, like, when you get into algebra in high school, and if you ever do calculus as an AP class, or in college, like, you'll continue to build off of functions and, like, the idea of functions. So, it's pretty important. But if you don't get it this year, like, don't freak out, because you'll come back to it when you do algebra a lot. So, okay, it says fill in the table of input-output pairs. So this is like the function is the thing in the box. That's also, you could call a function a rule if you don't like that word. Fill in the table of input-output pairs for the given rule and write an algebraic expression for the rule in the box in the diagram. That's like, x squared or something. So it says S, the side length of a square, blank, A, the area of a square. So that just means that somehow you're given a side length and then you get the area. So what do you do to get the area of a square from the side length? Well, you square it, S squared. That's what goes there. So if you're getting an 8, 8 would go here, and then you do 8 squared, and I believe that's 64. If I'm wrong, then catch me and fix it. But we're going to say it's 64. And then you do the same thing with those others. Yeah. Okay. Let's see. We have a big chart. This is activity 2. Diagrams, equations, and descriptions. Match each of these descriptions with a diagram. Okay, the diagrams are down there. Then it says, gives you A, B, C, D. So first, before we read anything else, we're just going to try to match each of these pictures down here, which I will highlight in a bright color. Down here, these things. We're going to match one of those with one of the descriptions, which I am going to circle in green as well. So we're going to match. Okay, so A says the circumference C of a circle whose radius is R. For those of you who forget circumference of a circle formula, it is closest to D. So I'm going to write an A above that. So I'm going to write a D next to this. So 2 pi r. That's the circumference of circle formula. B says the distance in miles D that you would travel in T hours if you were to drive at 60 miles per hour. So you'd end up having something like D equals 60T. Which looks very similar to B. So B and B are a match. So I'm going to write B. And then you're going to do the same thing with C and with D. And I think you guys can kind of rule out which one goes with which there. Over here in this diagram, you fill it out and let's just go. Okay, so description A, we said that's D. Description B, we said that's B, and you guys are going to do C and D. So for the equation part, what do they want you to do? Oh, yeah, you're writing like what it would be written as. So you're kind of like going backwards because what it equals, it's like if you were to look at B, you'd write like an equal sign here. So like D equals 60T. And then that's your equation. So I'd write D equals 60T. And then my equation for the other one is circumference equals 2 pi r. Oh my goodness, it's so hard to write small on this little thing. 2 pi r. Okay. And remember, you guys are doing C and D on your own, so don't leave those blank. It's saying, what if we input 5? What do we get for the output? So if we get an input of 5, 2 times pi times 5, that's like 10 pi. You don't really need to multiply out 10 pi. I don't care. I believe that you could plug that into a calculator if you needed to. For B, D equals 60 times 5, which is 6 times 5 is 30, so that's 300. Okay, so the independent variable is the one that is not alone on the side of the equal sign. So the dependent variable is the one that you're like having to find. It's like the output variable. So like for A, that would be, or for the one talking about circumference, that was confusing. Circumference would be the one that's dependent because that's the one that you're trying to find. And then the one that's on independent is radius. Because I think they're going to give you radius to help you find circumference. The thing of dependent is like, it depends on information. Depends on information. Okay. For the one talking about radius, the one that is independent is the time, because they're going to give you some sort of time. And then the one that's dependent is the distance, because that's the one that's on the end, the output end. Like you can't figure it out without some other piece of information. So follow that same format, but you now need to do C and D because we have not done those. Okay. All right, activity 3, dimes and quarters. I believe this is going to just require us to do a bunch of like simple math, but let's see. Jada has some dimes and quarters. Value is 1250. Relationship between number of dimes and number of quarters is this equation given here, which I am highlighting so I don't forget it. Okay, so 0.1 dimes plus 0.25 quarters. Well, that's because a dime is 10 cents, right? A quarter is 25 cents. The total is 12.50. So if Jada has 4 quarters, how many dimes does she have? So you're going to go and like plug it in. So 0.1D plus 0.25 times 4 equals 12.50. So 4 quarters is $1, so that's 0.1D plus 1.0 equals 12.5. And then 0.1D and the minus 1 equals 11.5. Divide by 0.1, divide by 0.1. And that would just be 11.5, but the decimal would move by 1. But I'm going to check with the calculator because I haven't done this for a long time. So 11.5 divided by 0.1. Okay, so yeah, the decimal just moves over 1 to the right, so then you get 115. So she has 115 dimes. It's a lot of dimes. That almost seems wrong, but I don't know what else it could be. And it is correct. I just checked. Okay. So you do the same thing with number 2. If she has 10 quarters, how many dimes does she have? Do the same thing that we just did, but instead of 4, plug in 10. I'm going to let you do that on your own, so you need to do 2. 3 says, is the number of dimes a function of the number of quarters? If yes, write a rule that starts with D equals blank that you use to determine the output from a given input. You can definitely say yes, because no matter what, you're always going to get one answer, and it's going to just plug in with that rule of how much a dime is worth and how much a quarter is worth. So you can say yes, and then we can say something like guess we can use part of their equation. So the book is saying something different than what I want to say. They are saying that D equals 125 minus 2.5Q. So what they did is they took this original equation, they multiplied it by 100, like that. So then that became dimes alone. So then that would just be dimes, and then that became 2.5Q, and that became 125. And what they did was they just subtracted over 2.5Q, like that. So, I mean, if you just left it as the original equation, it wouldn't really matter. But they just moved it around so it looks a little bit more clear as to, like, for 1 dime, this is what you plug in to figure out how many quarters, if that kind of makes sense. If it were a test and you just wrote your original equation, you'd probably still get pretty close to full credit. So we haven't really gotten into this enough for that to make much sense. So just don't worry about it if it's confusing. Number 4 says if she has 25 dimes, how many quarters? You guys can do that. Plug in, do the math. Same with number 5. What's number 6 saying? Is the number of quarters a function? Well, yes, because they're just reversing the order in which they're saying these two words. The number of quarters is a function of the number of dimes. And then it says, if yes, write a rule that starts with Q equals that you can use to determine the output from a given input. Okay, so I would say that you could just rearrange what we already have so that you have quarters equals blank. So if we have, you know what? Yeah, let's start with the equation we did for the other one. So D equals 125 minus 2.5Q. And I want to get Q on its own. So I'm going to go minus 125, minus 125. So D minus 125 equals negative 2.5Q. I'm going to divide by negative 2.5, negative 2.5. Going to get so 1 over 2.5, which ends up being, I don't know, use calculator, 1 divided by 2.5, 0.4. So this is 0.4D, and then plus 125 divided by 2.5, 125 divided by 2.5 equals 50. All right. So really all they want you to do when they're asking you to write it is a function of something. Just take whatever letter it is that they're talking about, like, is quarters a function of dimes? Well, quarters is listed first. So you're going to want quarters all alone and then just shift everything over, whatever you have to do to make that happen. Work with your original equation. That's pretty much all they're saying. You're just rearranging it in a different way. But it's still the same equation. It would still work even if you had never changed it. So they're just having you, like, look at it in a different way, if that makes sense. And then I forgot, this is negative. Okay. I hope that made sense. Is that it? Really? Oh, wow. Okay. So you got to do practice problems, and then you have a few to finish that we didn't go over, which I will circle right now for you. You have to do this one and number 2. I think we did all the others, did the hard ones. Yeah, that's it. All right, remember, join help sessions at 1:40 if you are confused.